move on to the project presentation of ICU.
Imagine you're standing in front of people ready to give a speech. You're nervous, you have butterflies in your stomach, and you're wondering, I'm so not ready to do this. But what if we could improve the speech without even having to speak in front of people? That's what this project is for. Something that sees you and improves one aspect of the speech, the body language, using computer vision. So these are the main objectives of this project: to enhance the body language skills of the public speakers by providing an analysis. And we do three things. Number one, assess the stage usage, assess the facial expressions and hand gestures, and then provide a feedback. So let's talk a bit about the background of this. So if we talk about computer vision, there are many techniques. For example, object detection, facial emotion recognition, and pose estimation. And using this, there are many applications that are built. For example, everybody can dance is something using pose estimation to help people dance. And emotional body recognition gesture recognition system shows the emotional gestures used by a person. So when considering public speaking, most of the applications are focused on the oral aspect of public speaking. So what I wanted to do was use the computer vision techniques in the public speaking context to provide an analysis of the body language of a speaker. So as I said before, there are mainly three parts: stage usage, facial expressions, and hand gestures. For both stage usage and hand gestures, we are using pose estimation. And for facial expressions, we are using facial emotion recognition. So talking of pose estimation, so we use PostNet for that. So as you can see, the 16 body points, 17 key body points of the person is identified. And for emotion detection, we built a model using deep learning to identify 7 different facial expressions. Those are happy, fear, neutral, surprise, disgust, anger, and sadness. Now let's move on to some of the experiments and results. So what I did was we took a speech, recorded a speech, and then analyzed it using our system. This is the analysis of the facial expressions of that particular speech. As you might be able to see, on the top left, we see the different facial emotions: happy, angry, neutral, disgust, fear, sad, and surprise. And throughout the speech, this value is analyzed from the speech and counted, so that the speaker knows how much of each facial expression is used by him. So moving on. So at the end, the user gets a report on how much different facial expressions he has used, so the speaker can get an idea of what he has done. For example, in this case, we see the neutral facial expression used a lot, which means the range of facial expressions was less, so which can be a learning point for the speaker. And we also provide a timeline, so you can see at each second which particular emotion was there. And to make it even more clearer, we get the average timeline of all this together. For example, in 10-second intervals, what is the most predominant emotion that was recognized. Moving on, we also identify gestures. Now, in public speaking, one of the most recommended gestures is the open hand gestures with your palms open. And another gesture that is likely to be avoided is the hands clasped gesture. So we define these two gestures and identify this and analyze the speech for these particular things. For example, as you can see, the open hand gestures, the count is given and different instances of these gestures are shown here. So next, we need to analyze the stage usage of the speaker. So for what we did for this was we divided the stage into several parts. As you can see, the speech is on the left and the analysis is on the right. So these green markers track the speaker throughout his speech. And we can see which part of the stage is utilized more or less. So at the end, he can get an idea of his stage movement and also the usage of the stage of the different parts of the stage, which will be a very important feature for the public speaker to know. So moving on. So this would be the stage analysis showing the different movements. And also we provide a timeline where you can see in each second at which zone was the speaker in. Now, just because you use the stage doesn't mean you use the stage well. You need to use the stage effectively. Now, one of the best ways to do this is to use transitions. For example, if you have two stories in your speech, after one story, move to another part of the speech so that it shows a transition to the speaker. So what we did was identify all these transitions using the system, and then analyze it and show it back to the speaker so that the speaker can identify, hey, at this particular person, I made a transition. Was this appropriate or not? So you can see on the screen, the speaker is on one part of the stage and he moves to another part of the stage. This is a transition which can be identified by the speaker. Next, this is Aaron Beverly, the 2019 World Champion of Public Speaking. When he talks about the speech process, he calls it read, you write, you read it, you record, listen, and then you rewrite, you reread, re-record, re-listen, and repeat. It's a speech is not just written once, it's written many times and honed. So we can use this system also to compare between two deliveries of the same speech. So this is a comparison between the hand gestures of two different two deliveries of the same speech. And this is stage usage, as the speaker can see any improvement from his previous versions of the speech. Now, one of the best ways to learn is to learn from those who have already done what you want to do. What better way than to learn from the world champions themselves? So I also applied this particular project on the speeches of world champions of public speaking in Toastmasters. So as you can see, this is the 2020 world champion of public speaking, Mike Carr, and this shows the stage analysis during his speech. And this shows the facial expressions that I analysis of the speaker. And I think you might be able to see a wide variety of facial expressions used by the speaker. As you can see, the counts of the different facial expressions are recorded. And you can see different facial expressions as used by the speaker. Now, seeing how such a championship uses such facial expressions is a great learning point for whoever wants to improve their public speaking skills. So these are some instances of the different facial expressions identified: angry, happy, neutral, sad. And moving on, we also applied the same transitions to the world champion public speaking as well. So you can see different transitions by the different speakers, by the speaker at different times. Now, we developed this for a system that uses a single camera. But I also improved this to be able to identify the hand gestures when the speakers were on stage. So as you can see, these are the finalists and the world champions of different Toastmasters World Champion public speaking. So you can see Dhananjay Hettiarachchi, Aaron Beverly, Ramona J. Smith. So you can see different hand gestures used by them. The open hand gesture, which is a very common gesture and very encouraged gesture to use, and the hand clasp gesture. Now, some of the limitations of this is that the video needs to be taken by a single stationary camera. Also, a single person needs to be within each frame. Also, the accuracy is a bit less when the entire body of the speaker is not within the frame. Now, we need to get feedback, right? So I got from the experts of this bit, the Toastmasters and Gavaldis. So some of the higher benefits that they highlighted was this system was not subjective. It did not depend on different people. And also, if you give us the same speech again, it will take several weeks, right? And the improvement will not be very marked to a human evaluator, but this system can handle it. Now, and this feedback also suggests that this product would be a commercial viable product because it really solves a problem that people have. Now, some of the future improvements that they suggested were to add matching and validating the emotions expected by the speaker from a particular story. What they said was different stories have different speeches have different stories, and different stories have different emotions. So by getting the emotion that the user expects and analyzing and seeing, is this actually the emotion that we see, will be a very big learning point for a speaker. And we can also provide quarterly reports, not just at the end of the speech, but also in the also in the quarter stages. So these are some of the suggested future improvements for the Toastmasters. Thank you, and over to you.
Thank you, contestant number 3. As a person interested in public speaking, I myself found this project to be really interesting. And I hope you all would agree with me. So with that, let's move on to the Q&A session. Do we have questions for our contestant number 3 from the panelists? And the audience, if you have any questions, please put them in the chat box.
Yes, I just want to ask about, I can understand about the sort of the gestures, right? But I think mentioned at the end about the facial emotions. So how does that, I mean, if I'm trying to sort of learn to speak, how does the knowing the different emotions going to help me in improving the speech? It's not very clear to me how that's going to be useful.
So when you're doing a speech, usually we use personal stories in our speech. And each story could be of different emotions. For example, if you're doing an emotional story, your face should express that emotion. If you're trying, maybe you're trying to show maybe a situation between you when you are very angry with your mother or something, and you can put that angry face. So that when you put facial expressions, it's much clearer to the audience what you're saying. So that's something that is very recommended by public speakers, to use facial expressions a lot to express what you're saying in your story or your speech. So that's why I put this, so that we can analyze. So what are the different facial emotions that we can identify and see, okay, I'm using a lot of facial expressions, or am I not using facial expressions?
So is that something that you have to know, like, okay, for this story, I need this type of expression. So therefore, then when you see this list, you understand what is the issue. But let's say I'm a complete novice and I have no idea about this, then I'm sort of lost, right? I see sad faces and all that, then I don't know what's, I mean, I'm thinking just, can you give a sort of a better feedback than that? Is there any way that you can improve on that?
Yeah. So in this case, what I did was just show the different ranges of emotions, so that the speaker can know what are the different ranges he has used. For example, in the speech I showed you, you saw that speech did not have a different, it was mostly neutral. So that could be a learning point to the speaker. Hey, I need to use a bit more facial expressions in my speech. But as you said, sir, yeah, we need to be specific to that person. And that was actually a point that was brought up by the Toastmasters, as I said, in the future directions. So when you give a speech, that when you're saying that this speech and emotional speech, so we can improve this. That's future improvement. We can improve. This is the particular emotion I'm going for. So, and when you analyze the speech, then and you get the different emotions that are shown, we can see what did the people actually see. Was it emotional? Did he see the emotions, or was it, let's say, neutral speech? That's sort of a thing that we can improve in future.
And how about the detector? I mean, how accurate is it? This is based on some existing detection method, right?
For the facial expressions, I just used a data set with different emotions, different images, and created a model for that. So that's about, I think, about 80% accurate, as far as I can remember. And for the pose estimation, for the pose estimation, I used the postnet that was an existing model.
Okay, right. Thank you.
Hello. Yeah, so this model is trained for different type of data set than the actual speaker, right?
Yes.
So is there a possibility for the speakers to customize and input some training data about own self?
Yeah, we could use that if you want, but generally what I wanted to do was emotions. So emotions, like different people have different emotions. So when I trained it, you get images from all the different people having different emotions. So hopefully it will be okay. enough to even, like as you saw in the speech, it detected the emotions correctly for the speaker. So I think that would be possible. Like if coming into facial expressions, customization, I think will not be a very important feature that we need to add. But if we want, we can do that.
Actually, but my concern was like for certain people, yeah, somebody's smile and somebody's like anger may sometimes in a photo can look like there can be like these confusions, like inaccuracies are coming from such cases. If somebody is using for own self, this customizable.
Yeah, if you did that, then the accuracy would be much more
higher. Yeah. And there are a few other application scenarios that comes into my mind, like where else can you apply this system or some slight modification of this system?
Yeah, I mainly focused in this for the public speaking context, maybe speeches and impressions. It could be used in different places as well.
Yeah, let me suggest you two areas that came up to my mind. You may sometimes think of those areas. One is like in counseling sessions. So it's very, I don't know how legal, how ethical, I'm not so sure. If the counseling could be analyzed for the expressions. Sometimes the expressions that the counselor misses, he can later watch the video and or get alarmed or get some annotations on the video. Right at this point, the counselor was in sad mood. There was some frustration, or sad or angry or something like that. And the other aspect, actually, we also wanted that for automatic lecture recording, that came up when you talked about the stage usage. So there were some videographic rules to allow walking. There are different terms, like I don't exactly remember. Various spaces you have to keep when a person walks towards a direction. So if your system can, in real time, recognize where the lecturer is standing, so you can adjust the camera to move to the correct frame and get a video, do the video recording. So that's another application. Yeah, so it's an innovative application of existing technologies and tools. Congratulations.
Thank you, Rafika. I think about that's a really good points that you said. Hopefully, I'll think about that as in the future. Thank you.
Okay, we have a question from the audience. This is about the libraries used in this project. And also, he wants to know if there is a considerable lag in detection too. Can you address to this?
For the libraries, in the sense, for facial detection, I actually used I created a model. So we used TensorFlow, and the images that we gave for different, for example, if it's a sad face, we gave a lot of emotion, a lot of images of sad faces. For happy, a lot of images of different people with different happy faces. And we use all these images together using TensorFlow to build a model, and that's what we use. And for the pose estimation, I use a library called, it's a model called PoseNet. So which detects the key points of the speaker. So this is what we use to analyze the stage usage and the hand gestures of the speaker. And considering the lag, for pose estimation, both the stage usage and the hand gestures, there wasn't a considerable lag. But for the facial expressions, there was a certain lag. But since we are giving a report at the end of the testing and we are recording a video, the lag, though it's present, was not a big issue at the end.
Okay, well, I keep on getting questions from the same person. Okay, like this one, there are three more. Number one, what is the frame rate of each of the detector models?
Yeah, so we use the same video that is coming in, that is the 30 frames per second. But as I said in the for the stage usage and the hand gestures, the frame rate did not drop drastically. It was almost real time, almost the same time. But for the facial expression detection, it dropped a bit, maybe about, I think, about 10 frames per second or something.
All right. The other question is, in real-time detection, it surely lost many frames. So that detections are not exact, right? So what about this?
Yeah, in real-time detection, what I tried was like if I started with real-time detection, that means I used my webcam and then actually did speech and then got it. But we analyze each, so a video is basically a lot of frames, right? So it takes one frame at a time and the next frame and the next frame. So even if you see it lagging, actually it takes all the frames. So we are analyzing frame by frame. So even though it's at real time and you might say that there might be a lag or something, but actually we are actually analyzing all and each and every frame. So then it'd be okay.
Okay. And also it says like all these, these three models cannot run parallelly. Do we have to wait until the results of one of the models?
Not really. There are three different models for hand gestures. There's one for special expression. There's another. So you can input the same video for all three, and you get the results at once.
Okay. And one more thing. What are you going to do to overcome this lag and to run all parallelly? What can you say for this?
Yeah, initially, so what we are doing is it's a system that gives you a feedback on your speech, right? So what, like if you go to a Toastmasters or Gather Club, like when you give a speech, you'll take a recording of the speech so that you can analyze it. So what we are doing is we just take this recording, you just input the recording, you get the feedback. So we don't necessarily have to be in real time, but what we get it is we get the speech the data on all these three aspects at the end, and we gave it to the speaker. So that's what the main purpose of the speech of this